So I'm using this triangle. Tangent is opposite over adjacent. So when I'm thinking that in my head, I'm thinking, oh, wait a second. I just said opposite over adjacent. In my chart, I don't want radicals in the bottom. I never want radicals in the denominator. So off to the side or on a scrap piece of paper, I'm going to rationalize that. And it comes out to square root of 3 over 3. Okay, so what I usually do is I fill in the first 3 and then the second 3, I kind of just flip them so that I don't need to remember too much here. So when I get to cosecant, they just go in this order again. I'm just going to flip sign. So if this is 1 over 2, I would flip it to 2 over 1. So cosecant, we would just say is 2. Okay, that wasn't bad. If I flip 2 over square root of 3, I would say, hey, I'm going to out to the side. If I have 2 over square root of 3, I'm going to rationalize that. I will get 2 square root of 3 over 3. Okay. And then last but not least, for cotangent, I flip tangent. That tangent was a simplified version, but I think we started here. 1 over square root of 3, so I just flip that. Square root of 3 over 1 will just be square root of 3. So basically all I'm doing is I look at that specific triangle, I'm saying opposite adjacent hypotenuse from the reference angle, and I'm filling in my 6 trig functions. Delightful. So our main goal today in class is we're also going to do 45 and 60. Once we have these 3, you're going to notice a lot of the other ones are very similar, so I'll show you what the similarities are after that. And then we also have to figure out what the heck do I do with the 0 and the 90 and all that fun stuff. So let's do 45, 60, and then we'll look at those ones. But they're pretty quick ones to kind of get into the hang of what you're doing. So I go back, I go to my sheet, you can go right on your Google Classroom, it's on there, and I look at 45 degrees. I had sketched it. I have found the reference angle, which is just 45 because it's in quadrant 1. I have made a triangle, and I have labeled the reference angle was 45, and then my sides are 1, 1, and then hypotenuse is square root of 2. Okay, so that wasn't bad. So from here, my reference angle's here. This is where I'm doing all my work from. Sine is opposite over hypotenuse. But I noticed in my head, oh, opposite over hypotenuse. I don't want that radical on the bottom, so I am going to rationalize that. And I get root 2 over 2. You can see my chart's looking nice. I do all this work somewhere else. You want the chart to be as neat as possible because it is something we use the rest of the year. The nice thing about this one is when I do cosine, it's adjacent over hypotenuse, but it's the same thing as what sine was. So that's just going to come out to square root of 2 over 2. I always like that one because sine and cosine are kind of the same. If I'm doing tangent, that's opposite over adjacent. So that would just be 1 over 1. Okay, that's just 1. Now, once I have those 3, I just flip them for the other 3. Now remember, the square root of 2 was simplified, but if I go back to the original and I flip this, that just gives me square root of 2 over 1. That's just square root of 2. And then that would be the same thing here, right? Because if those match, then those have to match. And then for cotangent, 1, if I flip that, you just get 1 again, right? Because 1 over 1 flips to 1 over 1. All right. So not terrible. Once again, if you have the little triangles in front of you, that makes your life a little easier. That's why we started that setup on Friday. But it's just kind of getting used to what goes where. You're going to see a lot of the same values because we only have 2 special right triangles, so there's only so many things we can plug in. So I want to do 60 with you, and I'm going to show you those quadrantal ones. So what I did is I sketched 60. I drew a triangle down, so I have a right triangle. My reference angle is 60. And then I fill in my sides. That would be 1. That would be square root of 3. That would be 2. Okay. But once everything's filled in, it's going to look very similar. We just need to make sure we're kind of staying organized. This is where all of my measurements are done from. So from there, sine is opposite over hypotenuse. Okay. I always like when it's kind of nice. You can just throw it in. You don't have to do any simplifying. From here, cosine is adjacent over hypotenuse. Once again, you just kind of throw it in. You're good. From here, tangent is opposite over adjacent. So square root of 3 over 1, I'm just going to write a square root of 3. Oh, those 3 were kind of delightful. The other 3 we're going to have to maybe do a little bit of simplifying. So once again, once I have those, I just kind of flip them. But if I had square root of 3 over 2, and I flip it, I do have to rationalize that. And that would give me 2 root 3 over 3. If I have 1/2 for cosine flipping, that's pretty easy. That would just be 2 over 1. So secant would just be 2. And if I had square root of 3, think of that being as over 1. I would have to flip that and then simplify it. And that would give me square root of 3 over 3. Okay. Those are going to be like, once you have those 3, you're going to notice, I'll kind of show you some quick little things. Your life is going to be way easier. So make sure those are written down and they're written down correctly. For 30, 45, 60. But now we're saying, well, we still have that 0, and what the heck do I do with 90? Because think about it. If I go over here and I say 0 degrees, 0 degrees is here. That's 0 degrees. How the heck am I supposed to draw a triangle? You don't draw a triangle is the main thing. You just pick a point on here. So I just pick a point. And I always make my life as easy as possible. We're gonna say that's the point 10. So we don't want to choose any crazy numbers. So if I think back to last chapter with x, y, and r, I would say that the x of this was 1, the y is 0, and if I found r by doing x squared plus y squared equals r squared, r is just going to come out to 1. So those are nice, easy numbers. And then I just remind myself, once I have x, y, and r, what the heck do? I just remind myself sine is y over r. Okay, so this shouldn't be too bad, because y over r is just 0 over 1, so that's just 0. Okay. Cosine is x over r. So just think about x is 1, r is 1, 1 over 1 is 1. So these aren't bad to fill in because the numbers aren't terrible. Tangent is y over x. So what would that be? 0 over 1, so that's 0. There's lots of zeros and lots of ones, and that's what's going to be really about it, because you don't have any crazy numbers. We do have to do the reciprocals, so just be careful when you have cosecant. In this case, it's r over y. That would be 1 over 0. Anytime you see something divided by 0, we know you can't divide by 0. It's one of those rules of math. Anytime you divide by a 0, we say it's undefined, so I just write UND. So that would happen if you ever have a 0 in the denominator. Secant is r over x. So that would just be 1 over 1. Okay, that one wasn't bad. And last but not least is our cotangent, which is x over y. In this case, x over y would be 1 over 0. I can't divide by 0. That would be undefined. I kind of like those ones. There's there's no rationalizing denominators or anything crazy. You have some zeros, you have some ones, and if you divide by 0, you put undefined. So I'm gonna show you how to set up the other ones, 90, 180, 270. 360 and 0 are coterminal angles. So if you have 0, you can automatically fill in 360 right now, because 0 and 360 are the same. So that's kind of nice. So let me just show you the quick little sketches for the other ones. You will maybe need these as reference, because when I say finish this on Thursday and you don't magically remember this, it's nice to have it written down. So for 90, just think about where 90 is, it's right here. So pick a point, we're gonna pick the point 0, 1. So x is 0, y is 1, r is always gonna be 1. For 180, that's over here. So that's the point -1, 0, where x is -1, y is 0, r is always 1. And for 270, that's down here. That's the point 0, -1. So the x is 0, the y is -1, and the r is 1. And once again, 360 and 0 are the same. So here's what I want you to do. Why don't we just do one thing at a time? You guys are gonna try 90 and 120. So let's start with 90, because it's basically just what we just did. So if I said, hey, can you find the 6 trig functions for 90 degrees? You would say, wait a second, that's kind of one of those weird ones where you don't really draw a triangle. So I set it up for you over here. You have x, y, and r. So basically, can you fill it in and fill in that row? So can you guys try 90 now? We'll check it in a second. Once again, this is why I suggest pencil. So you're just saying, can I kind of follow? Hopefully everything that you need is up on the board. But you can always look back at your notes as well. And you follow for 90. We'll go over in about a minute. And then we're going to set up 120 and you're going to see if you can follow that. And then we're going to look at some things that'll make your life way easier. Some generalizations. All right, so let's look. For 90 degrees, I go back over. We have written out the x, y, r, and then I reminded you what the ratios were. So sine is y over r. That would be 1 over 1. So I'll just write 1. Okay, that was that. Cosine is x over r. So that would be 0 over 1, which is 0. Tangent is y over x. So that's what I'm saying. I can't divide by 0. So that's where you write undefined for tangent. For cosecant is r over y, so that's just 1 over 1. For secant, it's r over x, so that would be 1 over 0, that's another undefined. Anytime you divide by that 0. And last but not least is x over y, that's 0 over 1, which is just 0. So it's okay if 0 is in the numerator, but when it's in the denominator, it's not defined. So does anyone have a question with how we filled that in? Okay, so I'm going to have you guys try 120, and then we're going to make a lot of generalizations, which will make your life a lot easier. So please try this one, because I do want to actually know what you're doing. So when I think about sketching 120, 120 is like right here-ish. It's in quadrant 2. I draw a line down. This is all in your Google Classroom. I'm just taking it off that kind of what you guys did for homework. The big thing that you need for this is the reference angle. And we said the reference angle in quadrant 2 is 180 minus 120, which would come out to 60. That's the angle in here. That's the angle I actually care about. So 120 is great, but it doesn't actually help me in my triangle. The reference angle is what I need. So this is a 30, 60, 90, 1 square root of 3, 2. The big thing is, since we're in quadrant 2, think about your x direction. You move to the left, so that's actually negative. That's up, so that's positive, and your hypotenuse is always positive. So this is the reference angle, the inside angle. So that's where you're doing opposite and adjacent and hypotenuse from. So if I asked you right now, hey, can you fill in the 6 trig functions for 120? So once again, from the reference angle, sine is opposite over hypotenuse, cosine's adjacent over hypotenuse. Can you do the 6 for 120 and see what you get? And then once we have the answers, we'll go over and kind of look at some stuff that'll help you out. So can you try that one now, please? I'll give you about, I don't know, a few minutes. And then this next part will be a very great use to you, especially on Thursday when you are filling in the rest of this chart. So we always want to make our life as easy as possible. So I will show you some things that will help you. All right, so about 30 more seconds, we'll start to kind of look at that and then talk a little bit about how you can make your life easier. All right, so I start and I say, okay, I know it says 120, but once again, I'm using the reference angle, so don't get confused about how we're setting that up. Sine, opposite over hypotenuse, so that's square root of 3 over 2. Okay. Adjacent from my reference angle is, cosine is adjacent over hypotenuse, that's -1/2. Okay, so this hasn't been going too bad so far. We know there'll probably be a little bit of simplifying somewhere. From here, opposite over adjacent, that would be opposite over adjacent. Okay, that's not bad, that would be negative square root of 3. Okay, so the first three, no, I was in the wrong column. First three are bad, I need to flip them for the second 3. So once again, if sine is this, I flip it for cosecant. And then I would have to rationalize, and that would give me 2 root 3 over 3. Okay. I can, for cosine, that's easy to flip. Negative 1/2 would just flip to negative 2 over 1, which is just negative 2. Okay. And last but not least, for tangent, I have negative square root of 3. If you think about that over 1, you would flip that and rationalize. And that would give me negative root 3 over 3. Okay. So I'm saying it's not terrible, especially if you have a triangle set up for you, but we want to make our life a little bit easier. The reference angle to this was 60. Hey everyone, look at 60. See how 60 and 120 are actually all the same values? The only difference is some are positive and some are negative. That is going to be of great use to you. So anytime your reference angle is 60, you can basically use that whole row. So you don't have to go back and do all the work, which is nice. The one thing you do need to remember is what are the signs? So we had written this down a while ago, somewhere in your notes, or it might have been on the worksheet. But let me remind you. The way we remembered it is we said, all students take calculus. I know that's not a true statement, but it's just like the little mnemonic device. And what that meant was, in quadrant 1, all are positive, which makes sense. For these 3, they were all positive because they were all in quadrant 1. In quadrant 2, sine is positive. That's what the S means. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. Now, please remember when I say sine, I also mean it's reciprocal of cosecant. Same thing, reciprocal as well. Reciprocal as well. So think about what that means. In quadrant 2, which 120 is, sine and cosecant are positive. Positive. Everything else was negative. So without actually even knowing that, it came out and it worked out that way. So here's how I would do the rest of this. 1, you have this sheet, or you can find the coterminals the reference angles by yourself. But this is now scanned into Google Classroom. You look at an angle. You find the reference angle. The reference angle for this, 180 minus 135, is 45. Once you know the reference angle, you find it, and you fill in that row. So ready? I just filled in this row. I don't even have to do any of that workout now. If you want to, you can. I'm happy for you. So since the reference angle was 45, I filled in the 45 row. I just need to check my signs. So in quadrant 2, sine and cosecant are positive. Everything else is negative. So sine and cosecant are positive. Everything else is negative, and you're done. So that's why I wanted to do the first part with you. Having that first quadrant is a very big use to you, because now if the reference angle, you need to make sure you have to find the reference angle, or refer to this, because I wrote the reference angles on it, so you can just go on your phone and go to your Google Classroom. But once you see, the reference angle is this, I can use that row, and then you just need to check your signs. It's way easier than having to go back and do every single triangle. But if you want to, you can, so whatever works. So we have about, a few 10, 15 minutes left. I would highly suggest starting to make out that chart. Maybe even we had written them up before, maybe do the 180 and the 270 now, so you don't forget how to do it, because those ones you do need to use the things that we had written. But then just start to go through and say, okay, what's my reference angle? What row is going to be of use to me? And then what are the signs? And your life is going to be way easier, okay? But I will warn you that your assignment on Thursday is going to be to finish anything. So if you do a lot of it today, that means you are saving yourself some time